Adam Ivy describes himself as an eclectic software architect, so I'm excited to see what that means. He's going to talk to us about DevSecOps, which is a topic near and dear to me, so I'm looking forward to that. He's going to describe to us how we can all better understand our guests while improving our data integrity. So with that, turn it over to Adam.
Maybe I'll leave the glass off the stage, stick to one of the plastic bottles. Thank you. Okay. So, get my talk rolling there. Oh, did I get a clicker? There we go. Chance. All right. Good to go. Oh, I started it too early. Okay, there we go. I'll have to give Donald a hard time because not only did I not use the template, I'm also not using PowerPoint or Keynote. It's one of my eclectic bits. So anyway, this is a story about DevOps, security, guest data, and all of us at the company, what we can do to better understand our data, get closer to our guests, and basically just enhance our data integrity for a lot of great reasons. So we all know about this old broken paradigm. We've been running away from this for years, where things are just fed through pipelines, thrown over the fence, everybody's in silos, nobody is happy in this ecosystem. Data is kind of weirdly attached to operations and production everybody feels is really hard to deal with. Security kind of comes in just to production. Luckily, we've moved far away from this. But key to this paradigm is that there's a big us versus them paradigm that grows in people's heads. Everybody's at odds because everybody has different needs that are not really overlapping into the silos. And so we've been moving toward this, more holistic, everybody talking to everybody else and working with everybody else around near real-time, high-quality big data. And in this, the product isn't just fed from one angle. There's a feedback loop, and it's driven by the data. And this is where we have a holistic empire around our product. But the key to it is this really removes the us versus them. This is really what all of the star ops things are about. It's just trying to get people more connected and get more of that perspective shared when we're trying to solve our problems. And we find really interesting things when we do this. If I had a bunch of data and I said to the room, hey, what do you want to know about this data? There'd probably be hundreds of different queries with a lot of different lenses that you would look at it with, from UX to security to compliance, dev flow, ROI, all kinds of reasons that we might want to inspect data. So there's this use case a couple years ago, some of you probably remember, when I was running the UNID service. And those of you who don't know UNID, it's a personalization data collection service that we run alongside OneID. And one of the things it does is it reports back to us the domain where the code was running. And a couple years ago, we started noticing that we were seeing our code run on Amazon.com and Wells Fargo and Chase.com and government sites and places that we wouldn't expect our code to be a first-party citizen. Through some deep investigation, we found this was a bug in Safari. Safari issued 3 very quick, successive patches to fix half a dozen different data exfiltration and cross-site scripting bugs that had existed in Safari for about 10 years. So this is a very old bug. And what's kind of scary about this is still 2 years later, we have 1 million users hitting us every week that have old, unpatched Safari versions. And so we still see our code running on these sites. But something we learned from this, 2 interesting things. One, this isn't really something that our security teams look at, right? We don't typically look and see, are we running our code? Is our code somehow magically appearing on Amazon.com? But from a dev perspective, when we see our code and we analyze what's coming into the data pipeline, we can see it happening. And then also discover from a developer perspective that there are developer standards out there for us in the browsers to help protect our guests. So rather than relying on them upgrading their browsers, we can actually implement the content security policy header, which whitelists what we want to actually run as a first party on our sites. So that led to the development of csp.go.com, which collects content security policy violations on the UNID script in its iframe on our sites. And from that, we can see that there's a significant number of authenticated users that have scripts that many of them are benign, ad blockers or style changes or whatever plugins they have running in their sites. But some of them are cryptocurrency miners. Right? We have things that we don't want running on our guests. And all right, it's not our job necessarily to police that, but it could be useful information if somebody calls in to customer support and we maybe can map that to this data and say, oh, well, we also know you have malware on your computer. So we know big data is out there. This is a sort of a short list of just the last 5 years of data breaches. Some of these are pretty big. Basically, everybody in this room has probably been part of a data breach. And if you were in one of the big ones like Equifax, it was over half of US households, there's some fairly sensitive information in there. And that can be linked with what is seemingly non-personal or not that dangerous information. So even an email that can then tie into this larger data set could be something that just enhances what's already out there. And it's kind of scary because there's a lot of cross-linking potential, right? It's pretty much everybody is affected by this stuff. So if we take a minute and we put on a black hat for brainstorming purposes, we can imagine some weird scenarios, right? I'm going to throw one out here, just bear with me. What if, okay, let's say like a nation-state actor or some kid in his basement who wants to impress his friends, takes a bunch of this already leaked data that everybody has access to on the internet, and puts it all together to try and create rich profiles, and then they slowly register accounts on some big company with lots of PII, PCI, whatever information they want. Maybe they focus a lot on child EU accounts because they know that's a really sensitive thing. And then they concoct a big visible data breach event, right? Like log in with the username and passwords that they created through one IP address all in one day, right? Which would look to anybody like, okay, something bad is happening to all these accounts. And then that triggers a mandatory reporting event, right? Which we would have to send to an ICO and then press release. Market might react to that. Somebody could profit. So crazy, crazy idea, right? This is totally nuts. But would we know if something like this happened? And that's the key to keep in mind. How would we know? Do we have that high confidence in our data? So if we take a look at it, we have about 350,000 registered users each week that come into our system, which isn't that much. There's about 330,000 people that turn 18 every day around the world. Not all of them are on the internet, so we're getting some slice of that, but there's kind of an ramp up that goes over time there. And there is some heavy spikes, right? We go from 35 to 80,000 users in some days. We know that some of our data is wrong. Some of it is fake. I mean, how many people here actually put their real birth date on the void form last night? I know not everybody did. People that are actually legitimate users will actually make up data sometimes because they don't feel comfortable giving it out. But not just statistically, we know just that you don't have to look that hard. About a month ago, I got a data dump of SWID, age, gender, and postal to do some age, gender prediction, and about 300 million records. Those of you who've done anything with machine learning, it's not magic. You don't just throw data at it. If you put garbage in it, you're going to get garbage out. So the first thing to do when you get a bunch of data is inspect it and figure out what's the quality level. How much do I believe that the truth data is really true data? And so I scrolled through this, just did a tail on the file initially, and what stood out was postal code data. A lot of it was really bizarre. And some of it's, obviously somebody held the shift key and ran over the number keys. Some of it's people just typing in random things. So from an initial data engineering lens, there needed to be some investigation there. And then I noticed that some postal codes actually had HTTP links in them, which kind of made me wonder from a security perspective, is there some place where that's being rendered or made as a link, or is somebody just hopeful? And some of these look kind of weird. There are our URLs or Facebook fake profiles that don't exist anymore. And then from an operational perspective, we put on that lens, we see maybe 100 characters is too long for a postal code. So that's our limit, and it's being filled up sometimes, and some of it looks like web scraped data, or there's this query time that's from 2008. Maybe that was data migration error, I don't know. So that's something we could investigate and make sure that doesn't happen again. And then this one's really interesting. When you put on UX glasses and look at this data, some of our accounts are unhappy and they're expressing that through the registration form, through this free form input. And so maybe these customers are specific, but it could be an indicator that there is a particular demographic that is not enjoying their onboarding experience, and maybe we could do something about that. These are just some of the minor, I plucked out and cleaned up some of these. There was a lot more. And then there were some really odd ones that kind of maybe rub the privacy compliance, like what's in this data? Maybe we want to run this through Amazon Macy and see if there's something in here that's not supposed to be. And then we have cases where the raw data, this one's really weird, had HTML encoded Korean characters, which raises two questions. One, because it would look okay if we actually executed that data as HTML on a page, but we don't execute data as code. That's terrible from a cross-site scripting perspective. So hopefully that's never looking okay. And then also, what happens if we send that to like a printing label? It's going to show up as HTML encoded characters when it goes to a printer. That's not rendered that way. So from a product perspective, why do we even have that data? Are we using it? And is that something we want to store? So I did not spend very long on this, looking at this particular set of data. But very quickly, at least 1% of that data, which isn't a lot, was just obviously bad. So a lot of email addresses actually in the postal field. I did not show any of those. About 3 million accounts are over 118 years old. And we have 158 time travelers from the future. So the cost of bad data is really high the longer you keep it. If you fix bad data right at ingestion time, it's fairly cheap. If you store it and then you fix it later, it's a little more expensive. Once it's propagated into your data lake and you're passing it to other teams, and then it's really expensive. So we want to track down, how does this stuff happen? Where's the entry point? Is it just migration issues from 10 years ago where some of this data is bad, or is it actually happening today? So we might wonder, why is 264 the upper limit for ages of guests in there? And now we had some guests that claimed to be negative 7,981 years old, and that one's easy to figure out because their birth date must be in 9999. And we have a whole arc permutation of negative ages from there on. If we look at the distribution graph, and I just cut off all of the under 0 ages, we see a couple of really interesting spikes. So huge spike at 69, 119, and a long tail to 264. So those could be some targets for investigation. If we look at the UI, we see that the lightbox limits age at registration time to 1902. It can be your earliest birth date. So oldest living person is 117. Maybe they want to register. Totally legit. If you register on an account that doesn't require a birth date up front, and then you go to a site that does require a birth date, you'll get a partial profile update request. And that form will let you go back to 1889. Not sure why, but there's a difference there. Now, malicious users, they don't go through our UIs generally. So I also had to try curling the API. And if you do it programmatically, you actually can get a birth date all the way back to 1753. This is interesting because it exposes that we're using SQL Server. So SQL Server, we switched to the Gregorian calendar in 1752. We lost a couple days in September. The SQL Server team just decided that there would be no time before 1753. So you can't create a date object in the database before then. All right, so there's 3 different systems. There's probably more systems imposing rules that I didn't look at right away there. That was a very quick investigation. But it's an interesting question that maybe we want to restrict the date of birth down to some degree. But maybe we don't want to restrict all the way down as much as we think is real. Because if we label fake data, instead of enforcing that fake data looks like real data, it's much easier for us to tell when somebody's making something up. Case for this, actually about a month ago, we had a reason to investigate our rate limiting for services. And we found that we actually had a huge band right at the top of the rate limit where people were hitting the edge. And then we had another huge band right at 50% of that rate limit. And all the traffic in both of those bands we had already labeled as malicious attempts. So our regular traffic was way below it. So by having a higher rate limit and allowing somebody to do something that was a little bit out of the ordinary, it adds another data point that helps us notice that this is irregular and it's not actually part of our high integrity data. So we want to look at the data. We want to look at all the data. We have things like New Relic, where we look at production information. But a lot of times what gets missed is that data behind the scenes after we collect the production data and we're running machine learning algorithms or predictive models or things like that, pulling out messaging and things. So we built this thing a couple weeks ago, a data integrity checker. This is where we finally get into the AWS portion. And we were solving this problem where there's lots of different people that run queries all the time. We have database analysts, business analysts, data scientists, and sometimes teams will get requests from legal or privacy to do an audit, to answer questions specifically, like we should have no registered guest with embargoed country codes in them. That's something that should always just be 0. So instead of having all these ad hoc requests and queries that are owned by a particular engineer on their machine or wherever, we decided, why don't we pool all of the queries that everybody cares about this particular product, put it in a Git repo, have that upload to S3, and then kick off an ECS job to run the queries, capture the counts that come out of those queries, and push those to New Relic. So right next to our production insights with real-time traffic, we also have, every 30 minutes we're running a whole bunch of queries to show what everybody cares about in the data itself. And we used Snowflake for this, which was super awesome because we could do queries that formerly took hours or days to run, now run in minutes or seconds. And New Relic just happened to be the place where we also have production data. But this pipeline isn't really specific, right? You could do this 100 different ways. The key point here is commit all of your queries that you care about so that you can share them with each other. And then we can have better insight into what we're actually tracking in our data. So if I could do one big takeaway for everybody here, when you go back to your teams and for yourself, think about, is there another team, is there another group that you see as them? That group that you either hand something off to or they come sort of ad hoc to ask queries from you? And is there a way that you can unify your needs on the data itself? And can you create some queries together, put those into a system, a repository where you all have this holistic view of what's going on in your data? Thank you. I do have a few minutes for questions, maybe. I don't want to take up too much time.
Any questions from the crowd?
All right. You can always hit me up on Slack. If anybody wants a demonstration of the integrity check runner or anything like that, our team can definitely sync up on Blue Jeans and do one of those.